external validity is the ability to take our model, estimate it based on one sample from one population, and use the resulting model, the estimated model, on a different population. Or we have different situations, for example, economic situations between the original population used to take or draw the simple random sample, and we want to use the resulting model on a different economic condition. For example, if you have a population, for example, population 1, and you take a simple random sample and you estimate a model, and you want to use this model on a different population, right? And what can go wrong here is that this first population is not a representative sample on the population, or of the population you would like to finally use the model on. So for example, if you have an experiment and you would like to use the model on the whole population, for example, you're testing whether or not exercise increases the O2 intake, then if you use patients with heart conditions, then you get one set of results, and then you have to think about, well, is this result, are we able to generalize this result to the healthy population? So to get a representative sample, in order to avoid this discrepancy, then we could take a simple random sample from the population on which we would use our model. Let's say that you have performed an experiment, and this experiment is going to be the foundation for a large-scale program. So you do the experiment, and you get some results, and these results, they are just rolled out as a large-scale program. And what you might find is that the program itself differs from the experiment. And in this case, we have a non-representative program. And this might come about because the program is less funded than the experiment because of political pressure or political processes, or the program is different because the participants are not as motivated, for example. And in our example, let's suppose that we are interested in finding the effect of reducing class size on resulting test scores, and that we find that a lower class size increases test scores. And the program that we study lasts only for the length of the experiments, which might be a few months, while the actual program continues for several years. So in this case, the program studied is different from the program that will be implemented later by the government. A third threat to external validity is the general equilibrium effect. This is the case where the environment changes because of the treatment. So, for example, turning a small temporary program into a widespread permanent program might change the economic environment. And because the environment changes, we cannot rely on the results from the experiment. So, for example, you have a web store and you change the design. Okay? And in the experiment, you get a certain result. Okay? The beta hat is your result, for example, on profitability. And what if you do this experiment, you find the causal effect of the change in design on profitability, and you turn this into a program, which means that you are rolling out the design to every single customer that visits your web store. And the program causes other web stores to change their design because they saw that your design was much better. So now every single web store in your field has the same design. So the effect on profitability from a change in design might not be as large in the final program as it was in the experiment.